Okay, in this video I will be doing percent composition, finding molecular and empirical formulas, things like that. And so I'm going to be working on number 5 on page 20 of your part 3 homework. Okay, so this is number 5. So a compound was found to contain calcium and oxygen. So I have calcium and I have oxygen in percentages of 71 calcium, 71.47, and oxygen 28.53. Okay, percent of each is the formula CaO or CaO2. Show your work to support your answer. So we got to figure out which one of these formulas is correct for this percent composition. Okay, and so what we're looking to do is find what are your subscripts, what is your mole ratio. And so when we find our mole ratio, this is where we use the percent to mass, mass to moles, divide by the smallest, and multiply until whole. So your first step is to turn these percentages into a mass. And the good thing about this is these percentages turn directly into the mass. So I'm going to, instead of putting 71.47%, I'm just going to put grams. All right, because we're going to think of this as out of 100, and so these percents turn directly into a mass. Both of these do. Okay, so from there that was step 1, mass to, or percent to mass. Our step 2 is turning these amounts of mass into a mole. And so anytime you're turning a mass into a mole, what you do is you divide your given mass divided by your molar mass. Well, here is your given masses. Divide each one of them by the molar mass. Well, what's your molar mass? It's your molar mass of calcium. Go to your periodic table. Calcium has an atomic mass of 40.078, and oxygen has an atomic mass of 15.999. Okay, so once again, what we're doing is turning a mass into a mole, because that's our step 2. So when I do put both of these into my calculator, 0.078, I get 1.78 moles for calcium, and I get 3 divided by 15.999, I get 1.78 moles for oxygen, and that's okay. And so in this case, both of these numbers are the same. All right, and so we're going to be dividing by the same number for both of them because they're both the smallest. In other cases, we're going to be looking at all of our mole numbers and figuring out which one of those numbers is the smallest, and then we'll divide each one of them by that smallest number. So in this case, each one of these gets divided by 1.78, and they both come out to be 1. So what we just did here, this was mass to moles, okay, divide by the smallest. This was step 3. And then the very last one this is your step 4. Multiply until whole. Now, the good thing here is both of these are whole numbers right now. Okay? If they were decimal numbers, then we'd have to multiply that decimal number to make that a whole number. But in this case, we don't need to do step 4 because these are both whole numbers, which tells me in calcium, I have a 1 here, and in oxygen, I also have a 1 here. All right? That 1 tells me to put that 1 there. That 1 tells me to put it there. So in the question, is the formula CaO or CaO2? I have found that your answer is CaO because those ones are not needed, they are implied, and so that's how you solve for that one. Okay, if I go to page 22, all right, this section here is a really good section because you're turning your molar mass of you're going from an empirical formula into a molar mass, or into a molecular formula using the molar mass of your molecular formula. So in this case, your empirical formula is given. All right. If it were not given, let me put it given, then you'd have to go through this step to get your empirical formula. This is an empirical formula. That's what we just found. Okay. So in this case, that empirical formula is given, and so for each one of these, we have to use the molar mass of your molecular to find out what your molar mass is over here. Okay, so if I do, let's do the last one, NO2. All right, so to find your molecular formula, you need to take, the equation is your molar mass of your molecular and divide it by your molar mass of your empirical formula. Okay, so here's your empirical formula, here's your molar mass formula. We need to divide this by that. Well, first thing that we need to do is find the molar mass of your empirical formula. So nitrogen, there is one of them. Oxygen, there are two of them. Oxygen is 15.999. Nitrogen, 14.007. So when I multiply that by 2 and add it to that, I get 0.07. I get a molar mass of 46.005. Okay, so a good idea for this section is to write your molar mass for each one of these compounds just below it. Because now what I can do is I can take 91.8 and divide it by 46.005. And that comes out to be 1.9995, so I'm going to think of that as a 2. Okay, now, so what do I do? How am I going to get the formula from that 2? What that tells me is that this empirical formula needs to get scaled up by the factor of 2. So that's a fancy way of saying multiply each one of nitrites, subscripts by 2. So this comes out to be N2O4. So here is your empirical formula for this compound. Here is your molecular formula for this compound. I hope that helps.